Okay, so next video for your next homework, 2018 paper 2 this time, to get ready for your mock in March. We've got a cylinder, it's got a movable piston, and it's showing us moving the piston outwards. And it says the piston's pulled in the direction of the arrow, but stays inside the cylinder. Perfect, so no air can get in or out. Which of these increases? The mass of air inside the cylinder. Well, if you could imagine, I'm going to have the same air inside as the start. None's gone in, none's gone out. The rate at which air particles collide with the walls, that'll go down. You can imagine at the start, it might have looked like that many particles ready to collide. I've got 2, and if I've got a bigger space, actually it won't be a volume like that. But if I've got the same particles in more volume, they're going to collide less often, so the rate will go down. Have I increased the volume of air? Absolutely. So the answer is C. Next one. We've got a rubber tube. It can be used in terms of a bike. Here we go. This is it before it's inflated. Is it after it's inflated? Fine. So what we're going to do, we're going to take air from the outside and put that in. It says the air inside the tube exerts an outward force on the wall of the tube. So the crucial thing to know, if I've got, say, a balloon, if I've got a particle, it's going to collide with air. Now, if I was to zoom into this area, what will I see? There's the surface, and all collisions are perpendicular to the surface. So the outward force will be perpendicular or 90 degrees to the surface, and you can see I've underlined that key part. Next part, we've got a question on the gas laws. So this is just going to check that we know P1V1 equals P2V2. That seems really complicated. I can put a little time sign in between those. But actually what it's saying is, if I've got, say, a balloon that size and a balloon that size, and if I've got the same number of particles in each, what this is saying is, well, if I did the pressure times the volume of that, it's going to be the same as the pressure times volume in that. This one, the pressure's gone down and the volume's gone up. So that's all that's saying. It's the gas laws that's got to be taught, and that will be taught before your GCSEs. So it says calculate the volume of air inside the tube. So what it's saying is I'm going to take 4 litres of air from the atmosphere. So that's there. It tells us the atmosphere is 100,000. So I'm going to set that to, that's going to be, let's set that to volume 2, and let's set that to pressure 2. That's all to do with the air. And what we're going to do now is take some of this air and we're going to put it into the tube, and that goes to 400,000. So we're now set up where we know the pressure and volume of the air, and I'm going to call that the P2 stuff, and the pressure and volume for 1 is what's inside the tyre. So we can set that up. We've got pressure times volume 1 equals pressure times volume 2. So this side here, that's to do with the tyre. So it's 400,000 pascals, this number up here, multiplied by the volume. We don't know that. And then here's the atmospheric pressure, 100,000 times 4.8 that was in the atmosphere. And I've looked at those. If I just do that, I mean, that was a crucial bit with me just picking atmosphere and atmosphere, so I know which go together. So now I can rearrange that 400,000, I can just do a little bit deleted here, is going to go underneath. So you can see that we're now left with V1 equals 100,000 times 4.8 over 400,000, and that equals 1.2 litres. Question done. Next one, when a bike pump is used to inflate the air gets warm. Ignore effects of friction. Why does the bicycle get warm? This is just the same question in terms of nebulae and how that turns into a star. So we've got this idea, we do work on the gas, and this increases the kinetic energy stores. So there's your thing. So work is done to compress the gas. Energy is going to be put in to squeeze these particles together. And then this increases the kinetic energy stores of the air particles. And that, I believe, is question 1 done.